Thank you, and welcome to the Child Welfare Information Technology Managers and Staff webinar series brought to you on behalf of the Health and Human Services Administration for Children and Families, Children's Bureau, and presented by ICF International. Today's webinar is entitled The Use of Web Services in Data Exchanges, and I am Joyce Rose, your host and moderator. Today's presentation provides an overview of web services, the different types of patterns used with web services, and their purpose in effectively exchanging data in real time between heterogeneous systems. You will be introduced to the concepts of service-oriented architecture using web services and how they can be used to integrate diverse repositories of data and to create efficient solutions for sharing and accessing data across the enterprise. Next, please. We strongly encourage all attendees to participate in our webinar with questions and comments. All of your participant lines are muted now, but we will open them for the Q&A session at the end of the presentation. However, I want to emphasize that the chat feature allows you to submit questions at any time during the presentation. Just use the chat feature on the right-hand side of your screen to enter your questions, and they will be addressed later on. Now, should we run out of time, we will respond to your questions via email. And if you have any additional questions, you may submit those to me at the email address listed on the slide.
If you have additional questions, please contact Joyce Rose by emailing joyce@kassets.com.
Also, if you have any topics that you would like to recommend as potential webinars, please do not hesitate to contact me. Next, please. So let's meet today's presenter, who is Valter Borges. Valter has served the Connecticut Department of Children and Families in the areas of database administration, reporting, data integration, consolidation, and data exchanges, and is currently the Director of Information Systems. Inspired by the work that DCF was starting to plan to modernize its SACWIS and eager to use his experience in application development, Valter began working with the team on creating a framework that would use modern technologies. At the moment, Valter's attention is focused on replacing the Connecticut SACWIS system with a new, modern, comprehensive child welfare information system. And now I would like to turn it over to him to begin his presentation. Valter?
Okay, great. Thank you, Joyce, and thank you, Elizabeth. Thank you, everyone, for coming today. I really want to also thank Pete Howe and the great folks at ACF for making this possible, and thank Commissioner Cass and the Deputy Commissioner Fernando for all their great support with CCWIS and all the IT initiatives. And finally, I'd like to dedicate this to my good friend Beth Petroni, who always believed in all the possibilities, and who we jokingly called the bus driver, because of all of her support and the integration work we did together. I'm also really excited to have this opportunity to be here today with all of you, and this is a subject I'm really passionate about, and I hope I can share some of my knowledge with you today, and that there's a good mix of folks from both the technology side as well as some business champions that are listening in today, so that we can, hopefully show you that you can empower your technology staff to use some of the techniques we discuss and to be able to develop some great solutions for CWIS. Okay, next slide, please. I'm sorry, the previous slide. So the objectives that we're going to try to accomplish today are, I want to describe to you how flexible and reusable web services are and how you can use them to share information with the various partners, state and federal. I would like to talk about web services, what they are and how they work, and really clarify, and simplify what it means to use web services. And I'd like to provide you an overview of how you can use certain different strategies for, depending on whether you're doing data exchanges, aggregations with mashups, building an API for your mobility, or trying to create a modular architecture for your CWIS environment. Next slide, please. So today we'll go into these different areas. I'll talk a little bit about the background of web services, what the business problem that web services solve. We'll talk a lot about the different approaches to web services, and I'll give you some recommendations at the end. Next slide, please. So throughout the years, I've heard a lot of people talk about web services, but I still believe today that there's a lot of confusion. So I'm going to be talking in this presentation about how to use and create web services. What a web service is and how it differentiates from a web app. We'll talk a little bit about the history of how web services came about and sort of the evolution. And they just didn't magically appear one day. They came really out of a field called distributed computing. And we'll talk about some of the features that it enables, like interoperability and loose coupling, which are features that you try to strive for when you're trying to build good software that can last and be maintainable and have all the good software qualities that make it desirable for software to be easy to implement and reuse. So next slide, please. So what's a web service? Well, there's different definitions out there. In essence, these are all valid definitions that you're looking at. I tend to like the third one the best. So to me, a web service is really a collection of open protocols and standards used for exchanging data between applications or systems.
A web service is a collection of open protocols and standards used for exchanging data between applications or systems. Software applications written in various programming languages and running on various platforms can use web services to exchange data over computer networks like the Internet. Definition from Stack Overflow.
The two systems can be written in different languages, C#, Java, any of the flavors that are typically used for languages out there. Most of the languages that are out there support web services, and they can be run on any platform, whether you're on a Wintel platform, Unix, Linux, you name it. You can use web services. Next slide, please. So when we talk about using web services, there's two components to that. There's the consumption side, when you actually call a web service and then get some feedback from it, and there's a language that allows you to query web services and find out what the service itself provides. We call that the WSDL, or the Web Service Definition Language. There's also, on the REST side, which is a technology I'll talk about later, there's also the WADL. But they serve similar purposes, so basically they allow the web services to describe what they provide for you. And as I mentioned before, web services can be consumed from a variety of platforms. So it doesn't matter if you have .NET, COBOL, CICS, Perl, PHP, anything else. There's probably a library out there for your particular language of choice. Next slide, please. So this is showing your typical web consumption interaction. You basically have a client. The client could be a PC, it could be another server, it could be a smartphone, any device that really has web connectivity and can talk over the web. Really connecting to a web server, which typically reside in your data center and in your back office, and which then typically talks to your data store, your database. The web service is being called and responding. It's being called over a protocol, which is HTTP, which is the protocol which the web rides on, and it's usually talking in a language either XML or JSON. Those are the two most popular flavors today, and so that's your typical web service consumption model. Next slide, please. So creating web services is a little bit more complicated than just consuming a web service, but not that much more. So again, the web services can be produced by and created in all those same languages that we talked about before. So whatever you have, you can probably produce a web service. I haven't seen many languages that can't. The language and platform vendors typically provide libraries that you can use to create the HTTP endpoints and serve out those services. You do have the additional task of deploying this and configuring it on your web server, which is a lot like if you've been doing publishing web applications today. It's very very similar to that. There's a few extra configuration settings that you may have to change to make the web service work, but if you're already doing web applications, you already know how to do this with just a little bit of guidance. And services can be used to consume other services and provide aggregate services, meaning I could have a service that calls a secondary service or calls a bunch of other services to create a better service. So these services can also be orchestrated, meaning they can be called in sequence and parallel to then provide sort of a workflow of data and information that can be put together to provide a bigger service. Next slide, please. So this is when you're creating web services, this is your typical environment that you have.
An illustrated diagram showing 3 tiers in creating web services. The client tier shows remote Windows clients, browser applications, and web services consumers, B2B. The business rules tier, web services, shows web service providers, SOPA/XML. The database tier, Oracle, MS SQL, Azure, includes SQL Server databases.
You'll have a web service layer, a tier where you'll publish your web services, and those web services will then be consumed by clients in the client tier, which you can tell it could be a variety of different clients. And then there's usually a backend that provides that web service with some sort of data from a database or a data store or another web service. Next slide, please.
An illustration showing the different layers of web services. The layers from bottom to top are application, components, service layer, orchestration, and presentation.
So what are we doing when we're creating web services? Well, today's application is if you look at your application, it's written, it has business logic. A typical web application will have n tiers of logic. So you'll have your data layer, you'll have your business layer, and then you'll have your user presentation layer. Well, what you're doing with a web service is you're really inserting another layer of code, let's call it, in between your business logic and your presentation. And what that enables you to do is, be more modular, allows communication with a lot more different types of devices, allows you to have more flexibility in your presentation, and allows for reuse of your software. Next slide, please. So a lot of times people confuse web applications with web services. A web application is really about a user interacting with a website or a program that's run on a website. It's usually the application is providing an integrated service, a monolithic service, and you have a web application behind it that is statically integrated in a bunch of components. Web services is a little bit different. They're usually not consumed by end users. They're usually consumed by another program or another application. There's some interoperability concerns that you have to address. They're usually aggregating other functionality that exists in your back office to bring that service together. Next slide, please. So I think it's good to understand that web services didn't just get created overnight. They sort of spawn from a lot of different technologies and inventions that came together to solve many different problems, and then sort of led us to where we are today. So what you're seeing is a timeline of and in blue you really have a lot of the underlyings of what was to be what we call today the internet, right? So you had the invention of modems, you had the development of packet switching, the invention of TCP/IP, DNS. These are the things that the protocols that allowed the internet to be built, and the network and the protocols that the internet relies on to be built, and in order for messages between different machines to be exchanged. really, at the same time, there's a lot of experimentation and work being done around messaging and the ability for different signals and messages to be sent in different types of languages that are able to describe data to be communicated between different devices, right? So TCP/IP was definitely a big one that enabled this. The invention of the web by Tim Berners-Lee, definitely another big one. The creation of XML and all the protocols and languages was also very foundational to what we know today as web services. Next slide, please.
An image of the Advanced Research Projects Agency, ARPA, network geographic map of the U.S. from September 1973, showing various locations and their interconnectedness in the early days of the Internet.
So this was just a quick slide. This is how the Internet really started. It was a few computer labs that were trying to do research back in the 70s, and in cooperation with the military's defense agency, Advanced Research Projects Agency, and together they decided that they needed a better way to share research, and they created the largest network, which we know today as the Internet. Next slide, please. This is just, again, a view of what we call the TCP/IP model, which is the underlying protocols and foundation that allow us today to exchange data between different computers and different networks. And so when we talk about web services, we're talking at the HTTP layer at the top in the application. That's the protocol that's going to allow us to use web services. Now, they all build on top of each other. So, for example, on the left side, let's say there's one machine and it has the TCP/IP stack. It's communicating over this protocol called HTTP, which then rides on top of the protocol called TCP/IP, and then it's actually interfacing with the network over a protocol known as Ethernet. Once the message gets sent over to the other side, the same thing in reverse happens. It goes through all these different layers. The message gets decoded, and eventually it comes up to the HTTP layer and the presentation of that service. So this is the technology that really enables us to be able to communicate between different networks and computers and supports web services. Next slide, please. Another big piece of understanding web services is that they use certain languages to communicate data between different systems. So a lot of work has gone on into trying to standardize that. Currently, the leading two ways of transmitting that data is between XML and JSON. So this all really came out of some work that IBM had done back in 1986 around markup languages and trying to solve how they were presenting different help documentation they had. In 1991, with HTML and Tim Berners-Lee really promoting HTML, that really pushed a subset of SGML to be created. In 1996, they then again used that same SGML language to create XML, which became the de facto and most commonly used way of transmitting data over web services. And recently, there's been also a big push to use JSON, which is another language. It's a lighter weight way of representing data in a structured format. There's also some new work being done to use YAML, which is a superset of JSON. But then again, XML and JSON are still the two most commonly used. Next slide, please. So, like I said, what occurred was really the convergence of all those technologies that came together: the web, the internet, all those web protocols being available, and all the work that had been done in remote procedure calling, messaging, remote methodification, which I'll talk about in a little bit, and being able to expose data and logic through a programmable interface. Next slide, please. So what is the motivation behind distributed computing? Really, this problem has always been there. We've always been trying to solve this problem, and there's always been some challenging problems in computing that require more than one computer or require multiple computers to be able to solve. And so we've always have tried to, in computer science and in the fields of computing, try to make solve problems in computer solutions by using multiple parallel computers. And in order for us to do that, we're always trying to be able to message and distribute the work and communicate messages between different types of computers. There's also another motivation is that we want to reuse work that we've done in one place and share it with somebody else. So over the years, there's been different approaches. There's a lot of work that has been done in serialization, which means taking bits and bytes in a program and data and converting it into text, sending it over a communication channel, and then converting it back into its native format, and then processing it. Some of the technologies that some of you that may have worked in this field before may be familiar with, DCE, which is really was one of the first to be able to commercial type of technologies out there to be able to do this. Corba, there was a lot of early success in the 90s around Corba. Java, the advent and the invention of the Java language really brought about a whole new level of and approaches to being able to remotely call other programs. One of the great advantages Java had over what had been used before with languages like C is that you could write a Java program and run it on different operating systems in different places, and so different programs can now communicate with each other in a standard way without having to, and could be distributed and run in different machines. So Java really, upped the game in the web services world, in the distributed computing. Microsoft was also had a big part to do with this, with the invention of COM and OLE, the ability for them to be able to use reusable libraries to link additional components and talk to each other. The creation of SOAP and XML, though, is what's been really the biggest driver of web services over the last 10 years. There's also, like I said, some newer protocols using REST and JSON, which are becoming very popular to do that. Next slide, please. So the traditional remote procedure call, as we call it, which means that you're calling a program that's remotely and you're executing it as if it was right there, sitting right there locally. And remote message invocation, that was a traditional way many years ago of doing web services. Today, there's the newer web services have a lot of additional benefits. Traditionally, you did this remote procedure calling within your own enterprise. You were tied to a specific set of programming languages that you did this with. So if you were using Java, for example, you stuck with Java within your enterprise to connect all the different machines talking to each other. You had that standardization across the board of using Java. You're usually tied to a particular way of transmitting the data, so a specific protocol. It wasn't, the different protocols used at the time weren't very firewall friendly. So that means, whatever channel you're trying to communicate, you had to do a lot of workarounds and opening up ports on your network to be able to communicate. And the languages were, the communication was efficient, but there were some challenges in trying to expand that beyond your enterprise. So with web services, you're able to go beyond the enterprise. You're able to ride on the internet and the HTTP protocol and take advantage of all the largest network in the world and the most standard protocol that exists today, which is HTTP. Everybody has a browser, everybody has a web server, everybody has an Ethernet network these days. So we're able to expand firewall friendly because everybody's already configured their networks to be able to allow HTTP. It's more maintainable and adaptable because it doesn't depend on you having a language in one place or another. It really depends a lot on the messaging and the protocol, around that you use. slide, please. So web services have really brought about an improvement over other previous known methods. They brought about better serialization. What we're talking about is taking, constructs, data constructs that exist in your programming languages, and representing them in a text fashion. So they can be read back in another application and translated into a different set of data structures, or a data structure in another, another type of machine. They've also improved security and encryption with web services. We take advantage of a lot of SSL as well as encryption within the actual XML itself. There's a lot of support for different protocols, so HTTP is popular, but it can also use many other different types of protocols, such as TCP, message queuing, message queues, and even name pipes. Web services can easily be deployed, so a lot of work in making it very easy to deploy. So if you have a web server, you can probably deploy a web service today. They're very reusable, meaning we can, leverage them and use them and mold them to do different things for us. They provide interoperability between different systems and different enterprises, regardless of whatever system you're running. And they give you a desirable software quality called loose coupling, which means that you're not building permanent connections within your software components, and you can sort of plug and play like Legos. Next slide, please. So interoperability, really quick. This is a characteristic that we try to strive for. We want those interfaces that we're creating between two different systems to be understood. We want the systems to be able to work together, and we want them to work together without restrictions. There is different types of interoperability, different levels. There's a syntactic interoperability, which means we sort of understand the languages that we're both talking on each side, and semantic, which means that no matter what different messages we're communicating with each other, we completely understand what to do with those messages without any translation. I don't think that that's a big thing to focus on, but I just wanted to say that there are different levels of interoperability that you should try to strive for. Next slide. So again, loose coupling, the definition of loose coupling, it's really about the degree of interdependence between the software modules that you're creating, and you want to create a system that is decoupled, and the reason for that is because you're normally putting a lot of logic in these components, and if they're all tied together and they can't be broken apart, systems become hard to maintain. The code becomes harder to write. Pieces that can't be reused as easily. So you want to try to introduce this concept of low coupling or decoupling, and you want to make sure that the different small, build the software in smaller pieces and deliver those components so that you have reusable parts. Next slide, please. So next I'm going to be talking about really the business problem that we're trying to solve with web services and some of the benefits around web services. Next slide, please. The typical problems that somebody would run across who would have a need for web services are they have legacy applications that they have to maintain, applications that have to talk to each other. They want a business wants to improve their productivity and efficiency. There's always those budget constraints, and they want to do things more effectively. You want to improve quality by bringing in data from the sources instead of having to re-enter data or recreate data, and you want to do it in a timely fashion. You also want to reduce your time to market. So if your customers are very demanding and you want to produce things faster, you want to be able to reuse so that way you can get to market faster and make those customers happy. You want to be able to control and manage your costs, and you want to create new channels for revenue generation. Next slide, please. So I took this out of the HHS Strategic Plan for 2017 because I also want people to know that HHS is fully behind the mission of interconnected systems, interoperable systems, look at this link, you'll actually find the full plan there. There's a whole section where it talks about, what, you should be doing to make your systems work together, talk together, and work in synchrony, and to produce better value for the fields of health and social services.
The excerpt from the HHS Strategic Plan 2017. HHS mission and functions require use of interconnected systems to provide real-time data to support everything from identifying public health threats to resource allocation and operational decisions on health and social service delivery. The full strategic plan can be found online at https://www.hhs.gov/IT-final-strategic-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-final-
goals that are in the larger document. There's really, the objectives are to improve the management of this data and the governance of data across all HHS agencies. They want to promote interoperability and the exchange of data, and they want to expand the engagement and provide usable and accessible systems and data. So today I'm hoping to show you how you can do that. Next slide, please. Other benefits of web services, they cut costs. Obviously, they create efficiency because you're doing less work in reusing things that you've already built and connecting things that were previously hard to connect together, so doing a lot less by doing it efficiently. You're streamlining and automating processes that may have been manual between, duplicate data entry, access to multiple systems. You're now automating those processes, making the software talk to each other, and doing a lot of that busy work that, people are, today having to do because the systems don't talk to each other. You're also improving the timeliness of data acquisition, which is a key component to data quality, and also for good decision making. Next slide, please. So next I'm going to be talking a lot about web services and some of the favorable properties, the message formats, and some of the architectures and the use of service-oriented architecture. So next slide, please. So some of the favorable properties, we already mentioned a few of them, loosely coupled, right? Encapsulation. So what encapsulation is, think of it like a black box, right? I don't need to know everything that your application does. I just need to know what service that application or that component provides. And so the idea is to wrap whatever functionality you have in that system with what your customers need and hide from them all the implementation details. We're also, the favorable properties are also about having standard protocols. So in the past, we've had all kinds of different messaging languages, different, types of formats. Well, with XML and JSON, we can now have standard formats that we can use to all communicate, so we're all talking the same language, and so we can all use, have an understanding of how to translate those messages back into their data states and the information they convey. We're invoking all this over, like I said, the biggest network in the world, intranet, or your internet, using the same technology, standard technologies, and we're able to compose a lot of different functionality from different business applications and programs and put it all into and mash them all up together so that we can reuse their functionality. Next slide, please. So, a typical web service conversation. Typical web service, let's use SOAP here in this case over HTTP. You have a client, you have a service listener, and behind the scene maybe a proxy, and then an application. That client is sending a SOAP message, which is being received, decoded, something is being done, so that message tells it, calculate, pi, and it sends out a response back as 3.14, 28 other decimal points. That message comes back, is received, and then processed. So two-way conversations can be had, one-way conversations can be had, but it's really about sending a message over that protocol. Next slide, please. I want to talk a little bit about the differences.
A chart comparing message formats, SOAP and REST. SOAP is an XML-based protocol, while REST is an architectural-style protocol. SOAP uses WSDL for communication between consumer and provider. REST uses XML or JSON to send and receive data. SOAP invokes services by calling RPC method. REST simply calls services via URL path. SOAP does not return human-readable result. With REST, results are readable, which is just plain XML or JSON. With SOAP, transfer is over HTTP. It also uses other protocols such as SMTP, FTP, etc. With REST, transfer is only over HTTP. JavaScript can call SOAP, but it is difficult to implement. REST is easy to call from JavaScript. SOAP's performance is not great as compared to REST. REST performance is much better than SOAP in that it is less CPU intensive, leaner code, etc.
So there's traditionally web services have been leveraging a lot of SOAP and XML. SOAP is really a protocol around how to create an envelope around XML that contains some additional information about the message that it's delivering. And XML is really the language that, the set of tags and language that describe that you can use to organize the message. So for those of you that have been around and, have created file formats before, we've gone from positional fixed position files to comma delimited files to formatted files based on spaces, tabs, and returns and things like that. The XML is really a structured way of conveying data, so that way you can represent hierarchical data as you would have with relationships in a database and be able to put all that together in a message that can be easily parsed, which is the action of going through that file and retrieving its different pieces and then processing it. It does return human readable results, so it's not a special format like binary that you can't read, so anybody can read an XML file. It can be called from a variety of protocols. It can be used from your browser, by a web-based application. JavaScript can call it, and the performance, I think, is for most applications is good. It's not as good as REST, and the reason for that is because REST is really streamlines that the amount of tags or semantic data that goes around the message. REST relies on a little bit different architectural protocol, which relies around calling URLs that are well-defined to produce certain behaviors on a web server. It can also use XML or JSON. A lot of times when you're using REST, you're likely to be using JSON as well. JSON is the JavaScript object notation, which I'll talk about in a little bit. Easy transfer over HTTP, easy to call from JavaScript. So if you're writing a web application, this is a really good way to go because it provides you a native way to call a web service. Next slide, please. So here's a typical XML schema. What this is doing is describing really what the data will look like, right? So we have what we have here is a node object or a node element, which has 4 properties: 2 from, heading, and a body, and those are currently in this XSD defined as strings. So text. Next slide, please. When you're actually writing the XML, here's what an example of that would be. I'm creating a note and I'm sending it to Tovi from Janny with a heading, a reminder, with a body, don't forget me this weekend. So that's the message that's being transmitted. This message needs to follow that schema, right? If you try to validate this message and it doesn't meet the format of the XSD file that you just saw before, it's going to fail and tell you it doesn't meet that standard. So you can pretty much define how you want to transmit messages and what your messages are going to look like so that there's an agreed upon standard on how that's going to work on both sides. Next slide, please.
A graphic of JavaScript is shown.
This is, again, the same representation of that same data, but in JSON. As you can tell, it's a little bit more streamlined. It's using, the brackets for objects and different semicolons. A lot less tags, only one in the front, just a lot more streamlined, but still represents the same data. Next message, please. Next slide, please. Next, we'll talk about some of the ways that you can use web services.
The 4 bullet points for web service uses are integration, data exchanges, APIs, and mashups.
Next slide, please. So, having worked in many organizations, and for those of you that have as well, had the opportunity to work in some large organizations with a lot of different systems, this is what you typically find. It's a spaghetti mess of different applications and different protocols and different technologies hooked together to produce some sort of result or a service for your end users and the consumers of your applications. And what I'm going to try to show you is how you can keep this mess organized and hopefully keep this encapsulated or abstracted from the users and consumers of your services. To provide, people that are trying to use your services, they shouldn't need to know all this just to get a simple answer from, one of your systems. You can hide this from them, this complexity. Next slide, please.
A graphic depicts a data exchange enterprise services bus. At the top is a row of 5 devices with the caption, Client Systems and Services. The next row depicts 3 servers labeled Application Servers, Mobile Client Servers, and Commerce Servers. The next row depicts Web Services. The next row depicts, from left to right, Java Messaging Systems, IBM MQ Series, etc. Then, Enterprise Services Bus, then Legacy, Mainframe, and Mini Computer Installations. The next row depicts Web Services. The final row depicts database servers and email servers.
So one of the ways we can use web services is really to integrate our existing internal applications. So the previous slide you saw with that spaghetti mess, there's typically a need for some of those things internally within an organization to communicate with each other. Well, one way you could go about doing that is by integrating your different internal applications by using what we call Service Bus, which we'll talk about later, but really wrapping each of those different applications and servers with web services. And so basically you're keeping the existing system and then adding another layer just to do that translation and to provide the ability for that system to create messages and talk to another system. And typically what ends up happening is once you build these web services, you want them to all be connected to what we call an enterprise service bus, which allows the messages to be delivered more reliably and allows you to more flexibility in how you want to orchestrate services, which we'll talk about a little bit later. Next slide, please.
A graphic is shown consisting of 5 ovals in a circle. Each oval is titled Web Services. All of the ovals are connected via 2-way arrows. An equation appears at the top of the graphic. The equation is n asterisk, open parentheses, n hyphen 1, close parentheses, /2.
What I recommend for folks to do is when they take a look at this spaghetti mess that they have in their environments is to create an abstraction layer, right? So you want to wrap your existing capabilities in a web service, right? Some of you, familiar with programming constructs might know that as the adapter pattern, wrapper pattern. But really what you're doing is encapsulating some of those services and hiding them from other environments. And then you can start having those web services communicate with another agency's, for example, set of web services. And that could be one-way, two-way communication. You'll usually start with one of the partners providing web service, somebody consuming it, and then eventually you'll get into, you need data from me, I need data from you, let's both do the same thing and create these web services. The problem with this is that as you start doing this more and more across different organizations or divisions or units, you end up running into, creating way too many channels and ways to consume web services. And so The next slide, please.
A graphic depicts 5 ovals arranged in a circle. They are labeled, clockwise starting at the top, DCF, DPH, DESPP, SDE, and DSS. In the middle of the circle of the ovals is a smaller circle. Each of the ovals connects to the circle with a two-way arrow. At the top of the slide are 4 bullets. 1. Service visualization. 2. Master data management. 3. Event correlation. 4. Semantic interoperability.
What we've done here is shown you a way where you can actually centralize some of the functionality around your data exchanges, and then have a standardized way for different agencies or units within your branch of government or your organization to talk to each other. So in this slide, I represented some of the agencies that we are going to have to integrate with here in the state of Connecticut. DCF, DSS, our State Department of Education, our folks at state police, public health. Just some of the examples. We are going to have a lot more than these to integrate with. There's some mandatory CWIS interfaces that you have to integrate with. But what I describe here is a way for us to wrap our existing environments with a web service layer, and then centralize some of the administration of those services, so that way you can, expose those services between the different partners, the trading partners, let's call them. There's also an opportunity to take things like master data management, things that are common to us all. So, for example, between 2 state agencies, DCF and DSS, we have a lot of the same clients. We want to centralize some of that operation, some of that data about these clients, so that we can all get on the same page and talk about, when we're talking about this client, we all know this client as the same person, and that simplifies a lot of when we're asking for different data on the clients and calling web services between our agencies, we can use the same IDs for those clients and know that we're asking for information about this client and not some other client. So master data management could be around your clients or people. It could also be your codes, your lookups, values that you share, locations, anything that you think that is a piece of data that you end up recreating or reusing across agencies, but it's really shared across all agencies. So you want to sort of build that in the hub. There's also other opportunities that you can take advantage of when using this type of architectural style, which is really event correlation. So if I'm putting a message on this bus, the middle piece, and some other agency puts another message, I can then have additional software that analyzes those messages and says, oh, I just saw something happen at DCF, and by the way, I just saw something happen at DSS. And I can try to make logic as to, these 2 events should happen, or they should never happen at the same time. So maybe this represents an event of fraud, let's say. And now I have an idea that, there's been some fraud committed in these 2 areas. And that's because, you could also use them to wait. You could have messages that come in from DCF that are waiting for another message that comes in from DSS, and then only when those 2 messages are coming in together can then another message be sent out to DPH. So you can do that event correlation and event composition to create even more better solutions, let's say. And this also helps standardize the interoperability between all the different systems. So next slide, please. So again, this can then be scaled to multiple levels. So here I'm showing an example how, having that same pattern that we just talked about can be then leveraged for at the national level as well.
5 data exchange diagrams are arranged in a circle labeled, clockwise starting at the top, Massachusetts, New York, Rhode Island, New Hampshire, and Connecticut. In the center of the diagram is a circle labeled NIEM. Around the circle are the words, clockwise at the top, HHS, CMS, FNS, and ACF.
So, same pattern. You can have states then transmit from their hub to the Health and Human Services hub. So today what we see a lot is different applications transmitting to different portals, different, formats, different mainframes. I believe that in the future we could standardize all that and have a centralized and way of working across all government agencies and transmitting data from states to the federal government in a standardized way using XML web services and some, in the slide there you see NEAM, which I'll talk about a little bit later. That's really a suggested approach to using XML and web services by the federal government, and put some additional discipline around the use of those web services and schemas and sharing of different types of structures for data. Next slide, please.
At the top of the diagram are the words third-party mobile app developer, with a picture of two individuals in front of computers with two mobile devices labeled external mobile. A horizontal line divides this from the bottom graphic, which consists of a single person in front of a computer with the label internal mobile app developer, and a graphic of two mobile devices labeled internal employee mobile apps. Each of these elements is connected to the word API with a two-way arrow.
So, another great use for web services, we all have CWIS, and if you've taken a look at some of those things that talk about the mobility in CWIS, you may be left to wonder, do I need to build a whole other entire environment just to support my mobile users? And the answer is no, you shouldn't have to. You should be able to, if you build your system using an API wrapped with web services, you should be able to expose those web services over the internet, over HTTP, to those mobile clients, and then leverage the same behind-the-scenes databases, behind-the-scenes workflows, all that business logic that you have already created and invested in CWIS, you should be able to reuse it, for your mobility platform as well. So this makes the cost of ownership for mobility a lot lower, reduces the effort, improves the experience and the consistency of your logic, and it makes it future-proof. Next slide, please.
A graphic is shown of a mobile device next to the Earth. Below and to the left is a graphic of 5 ovals, each labeled Web Services, connected to a center circle with two-way arrows. An arrow points from the Web Services graphic to the mobile device/Earth graphic. To the right is a graphic of a cloud labeled Cloud APIs. A two-way arrow connects the Cloud API graphic to the mobile device/Earth graphic. At the top of the slide are 2 bullets. 1. New integrated application, and 2. New data service.
So another opportunity that you have is to integrate those enterprise APIs with either other enterprise APIs or with cloud APIs. So there's a huge market in cloud services today. Last number I've read was over 19,000 different types of web services being provided out there. What this means is that a lot of times you're trying to create logic that may already exist somewhere else. It may be logic that it would, require a great number of resources for you to create within your enterprise. Well, you can leverage the cloud to provide some of that logic. It's the cloud, for those of you that have experiences, can also provides an elastic type of service. By elastic, I mean it can scale to different levels of use, allow for more users, more consumption of services, more computing power, without you having to build that within your enterprise. And then they expose those services, again, over web services, which then you can consume in your enterprise, thus giving you the ability to create, to really take advantage of some neat technologies like voice processing, file storage, Watson, for example, with artificial intelligence and speech processing. A lot of different types of services out there that you can use and bring the additional functionality into your enterprise by basically creating services that compound or use multiple services both from within your enterprise and from the cloud to make a better service. Next slide, please. So next I'm going to be talking about what a service-oriented architecture is. We'll talk a little bit about service buses, orchestration, and the concept of reliability. Next slide, please. So what's an enterprise service bus, and how does this differ from web services?
The graphic consists of 3 rows of boxes. The top row has one box that is rust-colored and labeled Enterprise Services Bus. The second row contains 4 green boxes labeled, from left to right, Asynchronous Queuing, Intermediate Routing, Policy Generalization, and Event-Driven Messaging. The first 2 boxes are connected to each other and to the top box with solid lines. The last 2 boxes are connected by a dotted line. The third row contains green boxes labeled Broker, Reliable Messaging, and Rules Centralization. The first box is connected to the others with a solid line. The second 2 are connected by dotted lines.
Well, web services give you that basic foundational ability to create endpoints that allow you to transfer that data between systems. But what they don't provide you is with all the tools to be able to manage that. So when you start building a lot of web services, when you have a lot of interactions between different web services, when you have timing constraints between the web services, when you want to support messages being delivered and being guaranteed to be delivered, when you want to support different types of policies and security around those messages, you want to have listeners on that central hub that I showed before, listening to certain messages coming in and reacting according to that. That's when you might need a service bus. So there are different providers of service buses. You can imagine the biggest companies out there that provide software today. I'm talking about the Microsofts, the Oracles, IBM, and a bunch of other ones all have enterprise service bus software, right? But they all basically do the similar things. They provide you with queuing capabilities, which means that I can deliver a message, put it on the bus, and then somebody else can pick up the message. So you don't have to have somebody listening on the other side, right? I could also have triggers that kick off other services or other messages to somebody else. What this allows you to do is really create a flexible architecture where you can tap in to a system, listen to what's going on with it, and produce other results without having to change that system that you originally had. So that's the concept of event-driven messaging allows you to tap in to and create hooks in your existing messaging so that you can create additional new capabilities without having to change your systems. Obviously, policies around who can use those services, the security around those services. You can have anything from like when the service can be called, a lot of different rules that you can configure around policies on services. Routing, you can route services, so you can create versioning of services. If you have different clients on different versions of your service, you can actually migrate them. You can virtualize the services and provide, using the same service, provide different protocols and channels that you can host for your service. Reliable messaging. If you want to be guarantee that message was delivered, and you want to get confirmation, that also service bus will provide that functionality for you. Next slide, please. So another big part of service buses and the software that comes along with the service buses is what we call business process management, but in more technical terms, orchestration.
The graphic consists of 3 rows of boxes. The top row has one box that is rust-colored and labeled Orchestration. The second row contains 4 green boxes labeled, from left to right, Process Abstraction, Process Centralization, Cross-Services Transaction, and Data Model Transformation. The first 2 boxes are connected to each other and to the top box with solid lines. The last 2 boxes are connected by a dotted line. The third row contains 3 green boxes labeled State Repository, Compensation, and Rules Centralization. The first box is connected to the others with a solid line. The second 2 are connected by dotted lines.
So orchestration is, a lot of times you have to take those services and you have to make them work together, right? You have little bits of functionality everywhere, and you have to make service A call service B so that you can have, everything that you need put together and delivered. So a lot of these tools are visual development tools that allow you to do drag and drop, configure services, a lot of work through configuration. You can also do some scripting and coding behind the scenes. A lot of them provide you that visual canvas for you to do this and sort of create workflows that you can test and run within that development environment. They also have a lot of features that allow you to transform. So the messaging formats, when you're calling one service, then talking to a different service, those messaging formats, the name of the fields that are inside those XML files, the type of data that you may need to receive and send out might be different. So you can use those service buses and that orchestration feature to transform that data and manipulate it from one end to the other. And obviously, it allows you to have a repository where you can monitor the messaging, and what we like to call, the messages can sort of live for a while, go to sleep, what we call dehydration. The messages can be reawakened at a later time based on some event and continue work. So sort of it allows you to create workflows with messages that allow you to compose a lot more business logic and rules and put them together. Next slide, please. So how does this apply to CWIS? And I'm going to also give you some recommendations. Next slide, please. So today, a lot of the systems that states have and organizations have a great dependency on legacy systems. Well, you can, there's a few things you can do. You don't have to, unless you're really looking to get away from that mainframe and save costs for some other reason. You can really reuse and adapt and create web services around those legacy systems. There's a lot of, COBOL, CICS, there's a lot of even third-party tools that provide the capabilities that you can then point it at a set of programs on a mainframe, have it automatically generate those web services and those endpoints, giving you the input and outputs, which you can then use to interface with that mainframe and continue to leverage all that business logic that you've developed. What this allows you to do is then slowly migrate off the mainframe as you need, instead of having to do it all up front. Another applicability with CWIS is really being able to create an API. So today we're migrating from one language to another. We know that this is going to happen again in the future. We know that these systems only last for so long, and things change in the IT world and in the languages at a really rapid pace. So by creating an API layer for your functionality and wrapping it around your CWIS modules, you're able to then plug in new modules, take out old modules, replace modules behind the scenes without really having to change your whole framework, and be able to be in this hybrid state of different versions and flavors of systems, but all unified through a web service API. Web services can also be used, like I said, to integrate new cloud APIs and software as a service platforms, and to bring additional functionality to your CWIS. If you're thinking about, for example, creating a new way to log into your services using multi-factor authentication. You may want to look at services that are out there on the web that provide this identity management software for your portal users, so if you have a lot of providers that are going to be logging into your portal, you may want to look at some of your identity management providers, which can provide you those services as web APIs, and then you can consume that and simplify your implementation of external identity management, login functionality, password reset capabilities for your portal. This is one of the many examples of what you can do with cloud APIs. You can also use this to create those patterns that I talked about, and reuse those for data exchanges within your organizations, within your state departments. You can use it to exchange master data, right? Transmit clients back and forth to each other. Whenever DCF has a new client, look it up in the master registry and it is shared with DSS. We call that the master person index. get that same client ID, make sure we're talking about the same person. Then we can go out to them and reach out and ask for information maybe about their income levels, or their we can reach out to the health department about if we're all using the same client ID, we can reach out and ask for let me see your health passport, let me see all your vaccinations, hospitalizations. I can reach out to the state police and ask for let me see a background check, let me see if there's any criminal activity going on. You can use those patterns that I showed you earlier to exchange master data. You can also use it to aggregate data from different agencies, maybe create an application that allows you to tap into all those back-end systems and functions as one application instead of having users being able to jump from different applications in order to do one function. It also allows you the ability to validate your data with other systems so you can have better data quality and enhance your data quality. If you know that somebody's capturing that data and already validating that data at another agency, you don't want to have to re-enter that data. You don't want to have to recreate it. You want to just bring it in, maybe show it to your users through a front end, have them just take a look at it, saves them the time from having to retype all that information again, maybe introduce more errors. And it also, again, like I said, gives you the capability to build mobile apps, which reuse existing logic, and really extend those services, in our example, in our case at DCF, to our mobile workers that are on the field. They need the information. They could use the time from not having to drive back to the office, having to fill out all that extra paperwork, having to scan and print and upload things they could have done while they're out in the field on their mobile application. So that allows us, but at the same time, you want to make sure that you have the same rules and all the same logic that applies to your to your data and to your system can also be leveraged. So that way we have good data quality and we're following the same processes. Next slide, please. So again, I'm going to leave you with some recommendations. I highly encourage you to look at those standards that were put out by HHS and the interoperability papers and guidelines that were put out by ACF. I hope that you've gained a little bit of confidence in implementing a service-oriented architecture today, and you understand now the reasons for how that can enable you to have more flexibility and create modularity within your CWIS environment. I think once you get into the world of using web services, I definitely encourage you to look into a service bus to help you to better organize your services and to orchestrate those services and manage some of the complexity around hosting and coordinating all the work in those services. Take advantage of some guaranteed message delivery and security and auditing features. I also really think if you're serious about this and you want to get into this space, you need to create a governance structure, which means you're gonna want to talk to your partners. You're gonna want to discuss and agree upon all these standards up front. You want to have the different constructs, different XML messages that you're going to be exchanging. You'll want to define those, and have a good standard for how you're going to communicate with each other and using these services. And then meet regularly to make sure that everybody knows what the different service offerings are and how the master data is being managed, how that orchestration is being managed, and the priorities for each agency that you're sharing data with. And finally, I definitely encourage you to look at NIEM, National Information Exchange Model. So there's a great tutorial online on NIEM. There's a certification that you can go through on NIEM. It really puts a lot of structure around how you create your messages and how you share your messages with your partners. And so it leverages the concept of XML, web services, schemas, and it talks about, how you organize that, how you communicate that, between the NEAM body that's creating the standard and your different partners, and how you can contribute the work that you're going to be doing to this greater NEAM standard, and maybe try to get some standardization across the health and human services fields and the child welfare field in terms of how we describe data and data elements, and how we exchange that data between each other. So again, I want to thank everyone that was on the call today, and with that said, I'm going to turn it over to questions.
Elizabeth resumes as moderator.
Okay, perfect. Justin, can you go ahead and let us know how people can line up on the phone for questions?
Yes, thank you. We will now begin the question and answer session. If you'd like to ask a question, please press star 1, unmute your phone, and record your name clearly. Your name is required to introduce your question. If you need to withdraw your question, press star 2. Again, to ask a question, please press star 1. It'll take a few moments for the questions to come through. Please stand by.
Okay, perfect. And if you prefer to type a question into the chat box, you can do so. You should see a small white arrow inside a little orange box, usually over to the right of your screen. If you click that, it opens up a larger dialog box for GoToWebinar, and there is a chat box towards the bottom. So you can also submit a question by typing in there. While we're waiting for people to either submit online or to line up on the phone, we do have one question that came in during the presentation. Can there be an enterprise service bus between agencies? And if so, who owns it? For example, who maintains security credentials for accessing web services? How would you go about creating and managing this interagency ESB if the concept is even worth implementing?
Sure, great question. Yes, it is worth implementing. And yes, you can have service buses that are implemented talking to each other. So if you, take a look at the slides and go back to the slide where I had the different agencies, each agency can create its own service bus, right? So all those same concerns that you have across agencies, you're going to have those concerns within your agency. We took a look at the spaghetti mess of different systems that can exist within one agency. And so to organize that internal chaos, you would want to use a service bus, right, to integrate within your own agency. Now, the center hub, and each agency would have their own. The center hub, what you saw in that diagram, that in itself would be another service bus. The two service buses obviously are communicating over XML, over web services. The service buses support all those different protocols. So yes, that is how the preferred method of how you would integrate the different agencies is through a centralized service bus, and that which gives you a lot of advantages in leveraging similar types of domains per se, like I showed you between DCF, DSS, DPH. You'd want to, obviously the buses are going to be doing something different. At the internal level, it's going to be integrating all your different components that you may have for an agency. So if you have 5 different systems within your agency that, legacy systems that need to talk to each other, you would integrate all that. And then you would expose some of that functionality out through that same web service bus to all the other agencies, which then would consume those services through that centralized bus. So as far as the security and credentials for accessing the web services, so there's a way that you can define. Here are the so you can use tokens for credentials. You can use passwords, usernames. You can tie it out to different identity providers that you have. For example, Active Directory. You may have some federated models. There's also SAML is a language in XML that allows for the exchange of secure tokens and identity tokens between 2 different sets of messages or services or service buses. So yes, you can secure those messages, and you can create the type of security as granular as you want around your web services for how those are to be consumed. Again, remember, these are to be consumed by most of the time other applications. So it's not an end user usually consuming a web service. It's another application. So a lot of times people do is just use they'll use digital certificates or passwords to make that exchange, that agreement that you're authorized to use that particular web service. So, thank you.
Sure, thank you. Justin, do we have anyone on the phone with questions?
We show no questions at this time.
Okay. I do have another question that came in online, although, Walter, I'm not sure if it's one that you're able to answer or if we've got some federal staff listening in who could push *1 and weigh in, but I will toss the question out there.
Sure, absolutely.
Okay. You mentioned possible future NEEM standardization. Are there any standard definitions/models available specifically for common OCS data objects? And if not, are there any efforts currently underway to create a standard structure?
Okay, so I got certified in NEEM about, I'd say maybe 4 years ago. That was around version 3.0. So you can go out to the NEEM website and you can register and you can learn all about NEEM. It's going to take you maybe, less than 8 hours. What NEEM describes is a way for you to create data structures and share those data structures within the constructs of XML with the NEEM standard. NEEM was really has been recently introduced to the health and human services space. Last time I looked at it, there was some basic models for defining, some basic things around users and some of the financial data that may go in an eligibility system I saw. But it doesn't matter if it's there or not, because the way NEEM works is you extend the existing NEEM. So you're taking a look at the data model that NEEM provides, figuring out, are any of these components that have already been made part of the standard, are there any there that I can reuse? And if not, you are able to extend the scheme and say, well, I don't see what I need in NEEM, so what I'm going to do is create it. Then what happens is you contribute that to the NEEM body of work, and you propose, and basically the NEEM body of work meets, and if there's enough, agreement and use around, a need for that particular piece of work, they will incorporate it into the NEEM standard. So the best way to make NEEM successful is for people to start building their data models and creating their data exchange messaging constructs and contributing to NEEM. That way, as a whole, eventually we'll all come across some, things that we have in common, like the way we describe people, the way we describe, a CPS report, the way we describe a provider, the way we describe a type of service that we provide in child welfare. If we contribute all those and the NEEM body of work sees commonality, they will incorporate it into the standard. So that's how NEEM areas or domains grow, is by contribution. So I have not taken a look at in the last few weeks, I have not taken a look at the NEEM standard, and I have not taken a look to see if they've incorporated any more in the area of child welfare, but I plan on doing that. And I would encourage you to do so as well.
Fantastic, thank you. Justin, do we have anyone on the phone?
We show no questions at this time. As a reminder, please press *1 on your phone and record your name if you have a question.
Okay, perfect. And I'd also like to remind everyone that you can click on the question box over under the GoToWebinar dialog box as well if you've got a question and just prefer to type it instead of asking it verbally. I do have another question that's come in. We currently consume web services, but are considering publishing web services for our extranet partners to consume. Is there a decision-making document that exists that could assist us in determining our approach towards web services?
There are many documents out there, I would say. There's a lot of different strategies you can use. W3C is a great place to start. There's an organization, I'm trying to think of their name now, OSRI, I believe. Oasis, that publishes a lot of information on and different techniques that you can use around web services. But I mean, what you really services externally, yes, I would say that's that's a great idea. I think you need to consider a few things. You need to consider what types of protocols you want to extend those web services on. So and that really you want to take a look at what types of clients would be consuming those web services, right? If you if you use a technology that can publish those web services and like a service bus that can then virtualize those types of web services for you, you don't have to worry about as much as if you're trying to create those web services, let's say in a JSON REST format and creating them just as URLs, right? Because if you lock yourself into just using those as a REST, then basically the clients that are consuming those services would also have to use that protocol. So you really have to decide, how do you want to, what kind of consumers are you going to have? How do you want to, expose these web services? There's also software out there that allow you to organize and publish your API, publish out the definitions of those web services, so those web services can be discovered. We didn't cover that today. That's the concept of UDDI and discovery. There's some software out there that also helps you manage that. Like I said, the other thing you want to consider is security. How are you going to make those web services secure? How are you going to communicate the intent of those web services? So now we're getting into the areas of describing your API, the documentation around those services. So it's a lot about understanding who your consumers are and how you can make it easy for your consumers to use that functionality that you've built for them. So how you go about slicing and dicing that functionality so they can then mash it up on their side. One of the theories is that you should really try creating small web services that have very granular levels of functionality, so that then your end users can then compose that functionality. Other theories are that you should create the service that is needed for that, regardless of the level of granularity, so that you can just deliver whatever is needed by the client. So you have to understand the intent of your web service. Is it to provide your customers with the ability to build the pieces themselves based on the smaller pieces that you provided? Is it to just provide data for them? Is it to standardize some sort of data to exchange between them? And that's going to help you make your decision. But definitely encourage you to do some research on that. And there's a lot of great information, like I said, on the W3C and OASIS. OASIS is the organization that is called for Open Standards for the Information Society. NEAM is also, the NEAM website also has a lot of great information about, creating these data exchanges and formats and services. So I would encourage you to look at that as well.
Okay, fantastic. And I have a comment from the original questioner saying that was really helpful, so thank you for that answer. Justin, do we have anybody else on the phone?
We show no questions at this time.
Okay. So just one last reminder, *1 for any additional questions or comments that you might have, and also you can enter them into the question box over in the GoToWebinar dialog box. And so we'll just give people another minute or two to see if we have any final questions. But in the meantime, Walter, I really wanted to thank you for this was fantastic information, and clearly you spent a long time preparing this and putting it together for us. So I really want to thank you for all the work that you did on this presentation and for being with us today and sharing this information with us.
Thank you. I just, again, want to reiterate that I appreciate this opportunity. I hope everybody's enjoyed it. And if you have any questions, please feel free to forward. I'm always looking on the listservs that ACF has. If anybody has some issues that they want to discuss around web services, I'm available, and I'd love to help. And I hope the the business champions out there today were listening, and they take this back and empower their IT organizations and their developers to work in this fashion and to exchange data, and together we can create a healthy data environment and data exchange environment for all our organizations. So thank you very much, everyone.
Okay.
And I hope to do some more of these in the future.
Oh, well, you know that we'll be calling you back about that then. So, Justin, I'll check in one last time and see if we've got anyone on the phone.
We show no questions at this time.
Okay, then Joyce, I'm going to turn it back over to you to go ahead and finish things up this afternoon.
Thank you, Elizabeth, and I too want to extend my thanks, and of course on behalf of ACF, a huge thank you to you, Valter. And I personally think Beth is smiling broadly knowing she left the house in excellent hands. So, in conclusion, we certainly hope the information shared with you today was informative and valuable, and as a reminder, please remember to register for the April ACF-sponsored webinar once the announcement is released. And I believe we are planning what is going to be a very interesting roundtable discussion. So, additionally, if you have any questions regarding today's topic, would like more information about any of our scheduled webinars, or would like to volunteer your state as a topic presenter, please do not hesitate to contact me or your ACF analyst. So, once again, this webinar has been recorded and will be made available online. When it is complete and posted, we will send a message via the SACWIS Managers listserv with the link. And finally, thank you all for attending. Goodbye.
If you have additional questions, please contact Joyce Rose by emailing joyce@kassets.com. A recorded version of each of the webinars will be available for viewing online at https://www.acf.hhs.gov/programs/cb/research-data-state-tribal-info-systems/training.